Physical Science. We're going to continue on with a couple more scientists that helped us understand the atom here in section 1. Again, we talked about Democritus, Dalton, and Aristotle, all about people making contributions, and we're going to keep moving on to the future. Again, Dalton was our first one to come up with an atomic theory, and so now we're going to take a look at someone by the name of Thomson. So what contributions did he make? His experiments provided the first evidence that atoms are made of even smaller particles. So we knew up to this point that atoms were the smallest thing that we can study, but now Thomson is saying that even within an atom, they are made up of even smaller particles than what we know. So the reason why Thomson kind of came in is one of the first things he noticed is that when some materials are rubbed, they gain the ability to attract or repel other materials. Such materials are said to have either a positive or a negative electric charge. So I would write this down, that the ability to attract or repel other materials, saying that because they have a positive or negative electric charge. So that's the reason why you either attract or you repel. So objects with like charges repel or push apart, and objects with opposite charges attract or pull together. So that is going to be, again, another big idea, and hopefully we've probably seen this before. If you have two magnets and you hold, again, the same side, again, both like the positive or the negative side together, you can feel them push against one another. Again, the same charges repel one another, but if you flip one of them around, they stick together. That's because one's positively charged, one's negatively charged. So opposites attract, like charges repel or push apart. So Thomson noticed that. And an example here is amber, which is a hardened form of a sticky, viscous liquid that protects trees from insects and disease. So if you've ever seen the movie Jurassic Park, that plays a big role in that movie. It's basically hardened tree sap is all amber really is. And if amber is rubbed with wool, it becomes to charge and can attract a feather, as you can see over there in the picture of the right. And we have amber being held there, and there are feathers that are actually being attracted to it, because again, it either gave it a positive or a negative charge. It gave it a charge that is opposite to whatever is present on that feather. So in Thomson's experiments, he took it a little bit farther rather than just rubbing some amber with wool. He used a sealed tube containing a very small amount of gas, and he had two metal discs on the end, and he had, as you can see, a metal disc, one is negative, metal disc one is positive, and he had a little electric current there, and he noticed, and actually we'll go to the next one to see what he noticed. And so again, he also put a positive plate and a negative plate on the top and the bottom as well, and he passed again this glowing beam of light through it. So I'll refer back to this picture as we kind of explain what Thomson did here. So when the current was turned on, so that's this glowing beam right here, you can see right here going from the negative to the positive, the disc became charged and a glowing beam appeared in the tube. So that's step one right here, the glowing beam appearing in this glass tube when they turned on the electric current. And he hypothesized that, skipped one. And a glowing beam appeared in the tube, so we said that. So Thomson hypothesized that the beam was a stream of charged particles that interacted with the air in the tube and caused the air to glow. So he figured the reason, again, he didn't just think this was magical light appearing. He knew there was some type of particles in there that was interacting with the air, and it caused the air to glow. And he observed that the beam was repelled by the negatively charged plate and attracted by the positively charged plate. So that's where we go over to the picture on the right. So we put the positive plate up here, he put the negative plate down there, and as we can see, this beam of light bends away from the negative plate. It wants to come up to the positive plate. So hopefully we can see that there. Again, this is over here on the left. The beam is in a complete straight line. He has not added the positive and negative plates yet. Puts the positive plate up top, negative plate down low, and the beam is repelled by the negative and it is attracted to the positive. And so based off of that evidence, he concluded that the particles in the beam had a negative charge because they were attracted to the positive plate. Again, we just said he knew that opposites attract one another. And so he hypothesized that the particles came from inside atoms because no matter what metal Thomson used for the discs, the particles produced were identical. So again, these discs that he used on the end, he changed these metals over and over again, but he always got the same results. When he put a positive plate on top, and a negative plate down low, it was always going to be attracted to the positive plate. So he knew that this beam of light had to be charged or caused by a negative charge. And he also knew that the particles had about 1/2000th the mass of a hydrogen atom, which is in fact the lightest atom. So the particles that he found had a negative charge and they were very small. So he knew that it wasn't the entire atom. He knew it was something that made up the atom, something a little bit, or actually quite a bit smaller than actually the smallest atom that we knew in existence at that time. So Thomson went back and revised Dalton's model to account for these subatomic particles. So subatomic is a big word here. Subatomic, and if you're sub, it means you're kind of below something, and atomic means atoms. So subatomic particles refer to particles that are going to be smaller than an atom. So he said the atom has neither a positive nor a negative charge, but there must always be some positive charge in the atom. And the atom is filled with a positively charged mass of matter that has negative charges evenly scattered throughout it. So he, again, to revisit, he revised Dalton's theory, and what he said was the atom has neither a positive nor a negative charge, but there always must be some positive charge in the atom. So he did not know where, but he knew that overall we could not say that an atom was positive and we could not say it was negative. However, it had both of those components kind of somewhere inside of it. So it's either filled with positively charged mass of matter that has negative charges evenly scattered throughout it. So that was how he explained the model of the atom. Again, positive charges that have negative charges scattered throughout. And Thomson called this model the plum pudding model, and today it might be called the chocolate chip ice cream model. That might make a little more sense to us, because the chips will represent the negatively charged particles, which are spread evenly through a mass of positively charged matter, which is the vanilla ice cream. So plum pudding was kind of something similar, a snack they had back then. Again, the pudding would be the ice cream, and the plums inside the pudding would represent the chocolate chips. But to make a little more sense for us, it's called the chocolate chip ice cream model. And you know what? We are going to stop just at Thomson's model. So Thomson is the only guy you need to worry about for tonight. So make sure you let me know if you have any questions.